Now we're going to talk about solving system of inequalities by graphics. So essentially all we're going to do is we're going to graph each line or each inequality, and we're going to see where the two shades overlap, and that's where your solution is going to be located. All right, so if we look at this first one, this would be the same thing as having y is greater than or equal to 1/2 x minus 3. All right, so just wanted to make sure you knew that. All right, so we're going to go ahead and graph that one. Remember that y-intercept is -3, and the slope is 1/2, so I'm going to go up 1 to the right 2. Then I'm not going to spend too much time about how to graph a line. I mean, by now, hopefully you should know. All right, so again, this is going to be a solid line, remember? It's going to be a solid line because this is an equal to equation. It's greater than or equal to. All right, now greater than or equal to means that I would shade everything above this line. Right? To me, that's pretty intuitive, because if it's greater than, you're going to shade above. If it's going to be less than, you're going to shade below. All right, so now on the next one, we have y is less than 2x. All right, so that means that my y-intercept is 0, and I'm going to go up 2 over 1. So up 2 over 1, up 2 over 1. And then down 2 over 1, down 2 over 1, down 2 over 1. Okay. And remember, this is going to be less than, so therefore, I'm going to put a dotted line across these dots. All right, so again, notice that this is a dotted line. Now, this is going to be less than, all right? So less than, it would be everything below this pink line. Everything below would be down here. All right, so if I were to shade that, and it's going to be kind of hard to see through that screen, but I would have all of that. All right, where the shade from this line and this line overlap happens to be right here. All right, so the solutions, all the numbers that end up being a solution for this two inequalities happen to be inside this. All right, and I just want to point out that if you have a dotted line, like all those numbers inside that dotted line, they actually would not work. All right, so and if it's on the solid line, that would work. So again, where the two shades overlaps, that's where the where the solutions are going to be located. All right. So the other one's going to work similarly. So I'm going to go ahead and skip to number 6. All right, so I'm going to go to exercise 6 here. I'm going to graph this. Again, this is y-intercept is 1, and the slope is -1 over 4. All right, so because of the same reason as number 4. So again, I'm going to go down 1 over 4. And then I could go up 1 into the left 4. All right. Now again, this is greater than or equal to. So I'm going to draw a solid line through those dots. Greater than would mean that everything above this line would be a solution for that type equation. All right, and on this one right here, I have a y-intercept of -1, and I'm going up 3 over 1. So 1, 2, 3 over 1, or down 3 to the left 1. All right, and again, this one is going to be a dotted line, because that doesn't have a little equal sign, right? So again, that's going to be less than. So less than happens to be everything below this line, all right? So below this line actually means to the right of it. So I would have something that looks like this, all right? So the solutions for this pink line, if you will, are to the below this line. Now, where the two shades overlap, that's where my solutions are going to be located. So it's about this little triangle here, right? So if you have trouble seeing that because of the way that I'm drawing this with a pen, I just want to show you quickly on the color calculator. Right, notice that I have basically this equation right here, and if I graph it, you can sort of see that shading, all right? That's everything above, and on the one on the, it's everything below, and you can kind of see this little area that looks like little tiny squares. That's where my solution is located. All right. Again, on the calculator, I can't really do a dotted line, a solid line, so that's about the only difference. Okay. So Anywho, if you go through the rest of these, that's essentially all you have to do, right? I'm not gonna do another example, but here's a couple. I'm just gonna show you the solutions that I come up with. You can kind of take a look at them and work on them on your own if you like, but that's essentially all you do. All right, so I'm gonna go ahead and go to the back page of your notes, and now we're gonna talk about finding the vertices, all right, in all these. So you can kind of read this on your own if you like to find the coordinates of the vertices, and it's actually going to be very simple, all right? So we're going to start off doing the same thing, but now we have 3 lines, okay? So I'm going to pick this to be blue, that to be green, and I'm going to pick another pen to be black. Okay, so the bottom equation is going to be black. All right, and hopefully you're able to see the different colors on the screen. So this first one, we have negative 3x plus 7, which means that the y-intercept is on 7. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so that's right here. Now the slope is negative 3. So the slope is negative 3, which means I'm going to go down 3 to the right one. All right. Now if you look at it, again, this is going to be a less than or equal to, which means that this line is going to be a solid line. Now instead of shading this, right, I don't want to necessarily make a mess of this paper, but remember, less than would mean that everything below here, right, everything below that line, which would be to the left of this, would be shaded. All right, now the pink line. Alright, the pink line, you have 1/2 x. And remember, if you cannot see a y-intercept, that means that the y-intercept is 0. So I'm going to start right here, and I'm going to go up 1 over 2, up 1 over 2, or down 1 to the left 2. And again, this is actually going to be a dotted line, because this is not equal to. Okay? And again, if I were to shade everything, it would be everything below this line, okay? So finally, on this part right here, on the bottom part, y is greater than negative 2. So y is equal to negative 2 would be a horizontal line across negative 2, right? So that's what we're going to do here. Negative 2 would be about right here. This is going to be a dotted line also. Okay, so on that one, if you look at it, all right, I'm going to probably do it in the calculator too so you can see it. Actually, I'm probably not going to do that on the calculator. If you look at it, this right here would be greater than, so you would shade everything above. This one should be less than, so it's everything here. And then finally, this one is also less than, all right, so where all the shades overlap happens to be this little triangle. Now, it will not always be, if you have 3 lines and they're enclosing a triangle, your solution may not be inside that triangle. So you need to understand that your solution is not always going to be inside those 3 lines, all right? So be aware of that. So the next thing they want us to do is for us to find the vertices. Right, which happens to be right here. The vertices are basically where all these lines are intersecting. All right, so I kind of made this a little darker for you. And in this case, all you have to do is just actually write them down. All right, so look at the coordinate at this point. If you look at the coordinate of that point, you have negative 4, comma, negative 2. On this one, notice that you would have 2, 1. And finally, you would have 3, negative 2. All right, so again, that's the coordinate right there, 3, negative 2. That's 2, 1, and that's negative 4, negative 2. So that's really all you have to do in this one, since the graphing, when you graph it, you can basically figure out where the points of intersections are, which in this case we call the vertices. All right, so on to number 2, same idea. Now, x is greater than -3, that's actually a vertical line across -3. And again, this is not equal to, which means that you should draw the line with a dotted line. Excuse me, that sounds really repetitive. Okay, now this one right here, we're going to say this is pink color. Now this is going to be 3, y-intercept of 3, and we're going to go down 1 over 3. So down 1 over 3, or up 1 over 3. Again, this is going to be a dotted line because it's not equal to. Remember, solid lines are only reserved for the inequalities that have an equal to sign on it. Alright. Then finally we have y is greater than x minus 1. So I'm going to come over here. That's my y-intercept, and I'm going to go up 1 over 1. And down 1 over 1. Again, this is going to be a dotted line. Now again, I don't necessarily want to shade everything because that would kind of obscure what we're trying to, the lines that I actually just drew. So remember, x is greater than -3. Now you have to think about it, instead of thinking about it up or down, you have to think left and right. X is greater than -3 would be everything to the right of this blue line that I have here. All right, so if you think about it, my solution is going to have to be somewhere to the right of this, right? Now you have y is less than -1/3 x plus 3. So remember, that's the pink line that I have over here. So less than would be everything below here, right? So my solution now is going to be somewhere in here, right, where between my two index fingers are. And finally you have x is greater than x minus 1. X is greater than x minus 1, which is the black line, would be everything above this black line, which will be, in this case, will be inside this little triangle. Okay? Now, remember what I said, it's not always going to be like this, right? Sometimes when you shade everything, you may not have your final solution may not be inside that little triangle. Okay. You just have to make sure and actually do the logic like we've done before. Less than is below the line, and greater than is above the line. Alright, so notice that I've kind of highlighted my vertices right here, and you just have to go and see what the y coordinates are, right? Notice that right here I have -1, 2, -3, so this is -3, and this is 1, 2, 3, 4, so we have -3 and 4 as one of the points of my vertices. Then I have another -3, so notice again -3, and then I have a -4. And then finally the coordinate of that point would be 1, 2, 3, and then up 2, so that means 3, 2. Alright, so finally on this last part, on number 3, I'm going to go ahead and graph them again. I'm going to try to do this relatively quick. And again, I'm separating these by color. Alright, so 3. So 1, 2, 3. Y-intercept of 3, and the slope is -1/2. So down 1 over 2, down 1 over 2. This one is 1/2 x plus 1. So this is actually up 1 over 2. Again, this is going to be a dotted line. And then finally, I think that probably the most difficult one to graph is 3x plus 10, and it's only difficult because if you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is off the graph, right? But if you think about it, the slope is 3x, so I can go up 3 and to the right, or I can go down 3 and to the left. So that should be my first point. Alright, so again, Notice again that if I go down 3, that's negative 3. If I go to the left, that's also negative. So that will make it into a positive slope. So there's another point. Here's another point. 1, 2, 3. Here's another point. All right, and again, this one also is only less than, so I have a dotted line. All right. If you look at all this shading, like I've explained before, it happens to be inside those 3 lines. All right, so now I'm going to look for my vertices. All right, so the first 2 are pretty easy. You can really see this one, hopefully. You can see that one, and there's another one right here, but that's the one that's going to give us a little bit of trouble. All right, so again, my vertices are going to be negative 2, comma 4, and then I have 2, 2. Again, this is 2, 2. Okay, and then I have, just make sure you can follow me, 1, 2, and then up 4. All right. Now the one that's troublesome is this one. All right. So that one, to find that one, you can't just do it by graphing because they're not whole numbers. Right. So what you're gonna have to do is you're gonna have to do substitution or elimination. Now on this one, I think it would be easier to do substitution. But if you want to do like with elimination, you can try if you like. All right. May not get there, but you can try. So if you look at it, this is the black line and this is the pink line, right? So I'm actually going to I'm going to use these 2 right here, those 2 equations to try to figure out the point of intersection. All right, so in this case, notice that what I'm going to do here is I'm going to say that, first of all, I'm looking for the intersection of the line. So really the less than or greater than don't matter. I'm just going to set them equal to each other. All right, so, excuse me. I'm going to write it as y is equal to 1/2 x plus 1, and this will be y is equal to 3x plus 10. Okay, so now what I'm going to do here is I'm going to substitute. Let's see what I want to substitute. I'm basically going to substitute this for y here, right? It says the y is this, so therefore I'm going to put all of this over here. And I hope that makes sense to you, right? If that doesn't make sense because we haven't done one quite like that, you can ask us tomorrow. So this we have, let's see, 1/2 x plus 1 is equal to 3x plus 10. All right, and we're going to try to solve that now. So notice that again, I have one variable. So I'm going to go ahead and solve it, right? I'm going to subtract 3x from both sides, and at the same time, I'm going to subtract 1 from each side. And now, 1/2 minus 3 will give us, you can write that as negative 2.5 if you like, especially if you have a calculator. In my case, I'm going to write it as negative 5/2. But again, if you want to write that as negative 2.5, you can. Right, so we have that is equal to 9. All right, and then if you remember how do you solve for this, you're going to multiply times the reciprocal, or if you wrote this as negative 2.5, you can just divide by negative 2.5. Use the calculator. As Ms. Shelton would say, don't be a hero. Words to live by. So this would be negative 18/5, and negative 18/5 would be negative 3.6. And again, I did this on the calculator ahead of time. Okay. So now I'm going to grab this x value. I'm going to plug it in either into this equation or that equation. It doesn't matter which one you pick, just pick one. All right. So in this case, I'm going to pick y is equal to 3. I'm going to pick that equation. I'm going to plug that in. So negative 3.6 plus 10. All right. So y is going to be equal to, I don't know what that is exactly, but I know that if I add 10 to it, because I've done it ahead of time, you get negative 0.8. Okay, so again, this is your y coordinate and that's your x coordinate. Okay, so that's actually the coordinates of that intersection right there. So that point right there would be negative 3.6. Comma negative 0.8. So that's the coordinate at that point. All right, I hope that makes sense to you, and we'll see you tomorrow.